Guys, we are going to be looking at the basic installation for a beginner. Okay, so as I said, people have been asking me, Proster, please just make a simple video on how to do basic installation. So it is not a day something for a beginner, but with time, when you are following our video, maybe you check us on our page, you understand the principle on how to do a basic installation. So for we not to make it congested for you, please, we are going to break it down: hybrid and non-hybrid installation, what you need to know as a beginner, and the information you need to have, and the awareness. So as I said our mission is one youth, three skills. So if you're not be following us, or maybe you have a younger one who have interest on our technical job, please subscribe to our page, and also send to your loved ones who want to have idea or on tech. So we will do our best to make sure that you understand what we are going to explain to you. Although we have already teach on the explain to our students on what basic installation required, and the things, the accessories you need. But because of time, we are just going to throw more light on basic installation because of the people following us online. So we need to also carry you people along. So now we are looking at a basic installation on the basic installation on inverter and a solar installation. So one I was talking about, someone was equally asking me, Proster, what is hybrid and what is a non-hybrid? So as a beginner, how is it going to connect a hybrid inverter and non-hybrid inverter? So as I say, we have different type of inverter, but we are going to be looking at hybrid and non-hybrid inverters. So one, as I said, we said hybrid what? Inverter. This is hybrid inverter. As I was saying, please, hybrid inverters has one of the features. One, you have what? Input what? You have input voltage. Two, you have a space for what? Output voltage. Three, you have what? PV. The PV mean for your panel what? Connection. Then four, you have what? You have what?
Battery.
The battery space. Okay. Where you terminate your what? Battery. So for the hybrid inverter, these are what you are going to see on your hybrid inverter. The input voltage, where you are going to terminate your input voltage, where your output voltage is going to supply the building. Then three, where your panel is going to be terminated, where that's where the PV, everything is written in that particular inverter. And four, where you are going to terminate your battery. But because of time, I don't want to make this video long. We are going to be taking it gradually, so you understand the protection system, how we are going to do it. So now, this is for what? Hybrid. Okay, please, can anybody give me other what? Hybrid. Okay, hybrid inverter. So we have other one again, two, non-hybrid inverter. Non-hybrid inverter. Okay, for non-hybrid inverter, okay, let me just say this is non-hybrid inverter. Non-hybrid. For non-hybrid inverter, what are you expecting to have in non-hybrid inverter? One, you have what? The input voltage, where you are going to which are what input voltage to your output voltage, where your output voltage is going to supply your building. Output what? Voltage. 3. What again? 3. Where you are going to terminate what? Your battery. Then 4, there is no PV. Am I right?
Yes.
So no what? No PV. In the area of this no PV, what are you looking for? So you are going to use what?
Charge
External what? Charge controller. Use what? External what?
Charge controller.
Okay. External controller. External what? Controller. In this external controller, we have two type of what? Controller. Locally, in our local market, we have what? The PMW, Abi? PMW controller. And we have the what? MPPT controller. So, but depends on the configuration, depends on the installation you are going to do, determine the type of controller you are going to use. Okay, so although we have already given our students some assignment on MPPT charge controller and the PWM charge controller, so now I'm going to draw an hybrid inverter for you and to see, just follow the step how you are going to control, how you are going to connect it. Okay, guys, asking for this drawing, please, Proster, just draw an hybrid inverter. Just bring out the layout. Don't put breaker. I know what to do next, so I'm going to do it for you. It's simple. Okay, this is an hybrid inverter. Okay, in hybrid inverter, you have a screen whereby it will display the information for you after your connection, whereby when you power it, it's going to display the information for you, your voltage, your PV voltage, your battery voltage, your load voltage. So we are labeling this place what? The screen. Okay, the screen. Okay, that will give you the information of your inverter. Mark you, in some hybrid inverter, they have a soft touch on their screen. While some you use the button to make a setting. Okay, so now, okay, let us, depends. Okay, right now I'm going to use, just going to demonstrate. These are on switch. This is for what? On and off switch. Okay, you will see other button by the side, small button for you to get for you to set, edit. You understand me? That is go back and like these buttons are what? For setting. Okay, then the other important things that you are going to be looking at in this hybrid inverter, I said hybrid, I'm saying hybrid what? Inverter. Okay, yeah.
Yes, sir.
Hybrid what? Inverter. So in this hybrid inverter, you will see, when you check under this is the information that you are going to be seeing. You will see L, INL. You will see some cases you see INN, and you will see E, or you will see E, this H, or you see something of this me 80, or you see E. This is telling you that this is what? Input what? Voltage. Okay, this is the input voltage we are talking about, and this is what? Input what? Neutral, and this is the H. it's very, very important when you are using hybrid inverter, you do your earthly proper. Then you will also see other information like this. You will see L in some cases, or you will see N, you will see L, and also the S symbol. But what you will see here, you will not see at output. Okay, this is output. Indirectly telling you what output, what neutral, and what output, what life and earth. Remember, all earth are the same. You can link the earth together. Then the other information you are going to see on your hybrid information, you will see PV. You will see a sign like this. You will see plus and negative. Then you will see PV. PV will be indicated there. You see PV. So this PV is telling that your panel connection is going to this what? This PV point. And again, you also have other information like this, positive what and negative. You will see battery, either BBT, or you see the display on full battery. So indirectly, they have given you all this information under your inverter, or you see it on your manual. So secondly, before you start any installation, there is what you are going to look at. You have to look at the faceplate of that particular inverter. For you to know what are you going to look, you have to look at the what? One, look at the what? Voltage. The VDC voltage of the inverter. Is it 12 volts hybrid? Is it 12 volts? Is it 24 volts? 48 volts? And so on. Hybrid system. That one will not determine the battery that you are going to use and your connection. And again, when you are connecting your panel, you have to also look at the VDC of your panel, of your inverter. The voltage, some of this hybrid inverter, you will see from the specification, they will tell you for 120 VDC to 500 or 550, just like that, or 1000, and that is 500, 600 VDC. Market. There are some occasions whereby someone have called me. I use so numbers of panel. I'm not seeing the PV voltage, the PV panel is not displaying on my inverter. Yes, in more cases, when we check, we'll discover that this guy use a panel of 250 at the worst case scenario. Maybe it's using a 6, connect 4 in parallel. It's using and the voltage we are looking for, they say from 120 to 500 VDC that can power this particular inverter. Now, this young man use 8. There's no problem in using 8. You can see he used 8. How many is this? This is 8. And the voltage of this panel, let us say is 27. Okay, it's 27 because it's using a 250. It's using 250. The voltage of the VDC is 27 VDC. 27. That is the opposite circuit voltage. 27. 20. Okay, now it connected 4 in parallel. Then another series it together. So indirectly, you cannot get up to about 120 VDC for it to power this particular system. So I don't want to make this video long. As you are following us, we are going to make it brief. We are going to talk about this particular connection, connecting 4 in series, and then connecting talking about series and parallel connection. Okay, with time. Okay, so someone in the audience here just said that I should explain, throw more light on it. Okay, should I throw more light on it?
Yes, sir.
Okay, so I'm going to throw more light on it. So now, this 27. Okay, now if you are connecting 27, can someone press this calculator for me? 27. If you are connecting this 8 in series, just say 27 times 8 in series. 200 what? 200 what? 16 VDC. So automatically it can power this inverter. So depends on the information you see on the faceplate determine how you are going to do your connection. You don't just start doing connection. Oh, it's a panel. Let's just connect in series. Let's connect in parallel. No, depends on the information, your data sheet that you have that will determine how you are going to do your job. So now, but this young guy connected 4 in parallel and then connected the two of them in series. So we are going to look at that 4 that he connected in series, and let's see if it can power the inverter. Okay, this is 8 panel. I will say each of the voltage is 27. And this is positive and this is negative, and this is positive, this is negative, this is positive, negative. Okay, now 4. It connect in parallel. 4 in parallel. In parallel. Okay. I'm going to draw this, do series and parallel connection, so that you understand what we mean when we are talking about voltage. And if you are talking about voltage and the ampage, you understand what we are talking about. Positive, negative, positive, negative, positive, negative, positive, and negative. So in this, so now I'm going to this is series connection. This is my writing, and this word parallel connection. So now in series now, we said these are what 27 volts. Okay, all these batteries are all these panels are what are 27 what volts. Okay, now these are also 27 volts. This is series, positive to what? Negative. Positive to negative. Positive to negative. There it's going straight. If you connect 8, okay, just for this 4, 27 times 4, 108. Remember, if it's 108 and the manufacturer said 120, it cannot power this inverter because the manufacturer said what? 120 and above to so voltage. This 108 cannot power. You will not see it on your screen. So, but for this young man, see what he did. In a parallel correlation, positive to positive, negative to what? Negative. Okay, this is what he did. Now, in this case, it's still remaining. Everything here remaining. This in series now is giving us 108 watt volts. I think you times this 27 times 4, 108 watt volt. But in this case, the ampage we what? We remain what? The same. Why the voltage will increase in series what? Connection. But in parallel connection, what will happen here? The ampage will increase and the voltage will increase. Okay, thank you. Now it's 27 watt. It's still remaining 27 volts. So indirectly, if you connect other 4 again in parallel, do you understand? If you connect other 4 in parallel, they must series is together. What you will have, you now have 27 times 2, which is what? Okay, 54. So indirectly, it is not possible for you to power this, even though you connect them in 8. and you now power you connect 4 in parallel, them are series, then it cannot power this system. Am I right? Then now, if you connect other 4 in series, you will now have what? 27 times what? 8. What is it going to give you? 200 what? 200 what? 16 what? VDC. It means that it can power this what? Inverter. Okay. So now, this our, okay, sorry, very brief. Let's assume this our panel. So we have discussed about the panel. We said 8 to say, okay, depends of the information that you see. So just take the positive and the negative of this your PV straight. Can you see? Okay, for your panel. Straight to where it is written PV under. Okay. Then if this inverter, maybe from the manufacturer specification, it said 48 volts. Okay, we are using what? 48 volts. Okay, let's use 48 volts in this system. So please, can you just permit me, what battery do you think you feel that we are going to use? We have the, okay, which you use a tubular battery. Okay, so we have the note, we have the SMS battery. This is the self-maintenance what battery, and we have two. We have what? The tubular B? Yes. Tubular what? Battery. And 3, we have what? Lithium battery. Lithium battery. Lithium battery, okay. We have the lithium battery. So the SMS battery, these are self-maintenance battery. While the tubular battery, they are the wet cell that you top up distilled water for maintenance. But lithium battery is different from this tube battery. Okay. Yeah, you said we are going to use a tubular battery. Okay, note, we are going to do something. I believe you already understand this. So now, this is your tubular battery. It has a 6 compartment. Okay. 1, 2, 3, 4, 5, 6. As you can see, at the top here, you see there's a gauge here that indicates, and most of this battery there comes is what? 12 volts, and the ampere either 220 230 amps. Okay. Yes, sir. 230 212, but each of these compartments is what? Each of these compartments is 2 volts. 2 volt, 2 volt, 2 volt, 2 volt, 2 volt. So it's connected in series. That is why it's now what? 12 volt. If for instance this particular tubular battery is connected in series, that is, it's connected in parallel, you will see that it will remain 2 volts, while the amperage will increase. The amperage, if this one is, if for instance one of the compartment is 220 amps, you see that it becomes 2 volts, 220 times 12. That is 220 times 6. I'm talking about the amperage now. 1,320. 1,300 what? 20. That is 220 times what? 6.
1,320.
Okay, 1,320. What? So 1,320 what? Amp. That is when you connect what? In series. Then it remains what? 2 volts, 1,320 amp in one compartment. But in series it becomes what? 12 volts, 220 what? Amps. So I just want you to understand the difference between what? Series and what? And parallel. Okay.
So please, when you get faulty, is it advisable to
what?
maintain it alone or we'll take it to the manufacturer.
Yes, because if it's faulty, depends of the damage the battery have for tubular, you can do it yourself. You can maintain it yourself. But if you know that the cell cut, and I will teach you how to test for cell, but not in this particular topic. So if the cell cut, please take it to the service center where they will help you out. You can't do it yourself. But if the the water is corroded, so you can do that maintenance yourself by replacing it, then charge it up, it will come back to life. Okay, now secondly, let's not deviate from what we are discussing. You said we tag this hybrid inverter 48 volts. Am I right?
Yes, sir.
So this hybrid inverter is 48 volts. So if it's 48 volts, it means that we are going to use four numbers of what? 12 what? Volts battery. Okay, this is it. They are all 12 volts. Okay,
Yes, sir.
positive, negative, positive, negative, positive, negative, positive, negative. So now, for us to have, they are all 12 volts. 12 volts. Okay,
Yes, sir.
so you have to connect in series for you to get what? The voltage. Okay,
Yes, sir.
positive, negative, positive, negative. What is meant is left with what? Positive and negative.
Negative.
So if you times it now, 12 times 4 is giving you what? 48 what? 48 volts. So straight, you can see how is it coming. This is what? This is the battery. Under your inverter, you will see those information, all this information under you from your manual. Okay?
Yes, sir.
You can see. So now you can see that we have succeeded in connecting our PV, that is from our explanation. Now we have what is left here is left with what? The input voltage and the output what? Voltage. So although this connection, we have a lot to do on this connection because there's no protection system, there's no breaker, but this is just for a beginner. So we're also going to explain that in our lens, how to put your PV, how to your
Breaker.
protection system, your breaker, your SPD,
Surge.
your surge. So we are going to do that. Your ET system, how to test for it that is okay. So we are going to do that. Now it's many what? Input and output what? Voltage. Mark it. At this point, now with this panel and battery, you can power your house. Let's assume there is no input, there is no grid in your environment. Let's assume your villages or your city, there is power failure, there is no grid system working. You can decide to do away with the input. Okay, with the input what? Voltage, and go straight to your output cable to feed the house. I'm going to make here extension. Just at your house, you understand me, and this your at it. Let me call this extension. Okay, your extension box. Okay,
Yes, sir.
is it clear?
Yes, sir.
So this is your plug where you are going to plug your things. If for instance maybe there's no changeover, this is just for a beginner. Okay,
Yes, sir.
so this is European standard extension that have 3 man, but the German standard has what? 2 pin. Okay, so now you can introduce your fan, your TV socket, and plug it here. Okay,
Yes, sir.
and this is your fan. Okay, let me assume this is your fan, your standing fan. You can take it and plug it here.
Yes, sir.
So now it's working. Just turn it on. You see that it's working. All the information on your inverter, it will display all the information here. So okay, now I want to introduce my grid. Okay,
Yes, sir.
let me introduce my grid so that when there's no sun, my grid can equally charge my battery. Oh, I'm going to do this our grid line. We have three phase. We have line one, okay. We have neutral, okay.
Yes.
Line one, line two, line three, okay.
Yes, sir.
So mark it. The down line is always what?
Neutral.
If in Nigeria, I don't know about other country, but in our country and in our neutral is always coming from here. So please take it what?
Neutral.
To neutral. Then you can take, it's a single phase inverter. So what you are going to do, just take any of the phase, this. So now it's complete. Then make sure you edge your inverter system. So I believe with this we have actually do a basic schematic diagram on
Installation.
how this installation is being done. Is there any other question maybe you feel to ask? Please just ask. We are ready to answer you. Is it clear?
Yes, sir.
Okay. So guys, thank you. As I said, follow our page. Is free of charge. If you have any issue, please write us. We will reply you back within 24 hours. So thank you. God bless.